Geometrical implications of the factor theorem. A polynomial p of x with degree n has a unique graph that passes through n plus 1 distinct points. So for example, the graph of p of x equals x squared, so quadratic polynomial, degree 2, its graph is a parabola, passes through the points -1, 1, 0, 0, and 1, 1. So there's degree 2, so n equals 2, and there are n plus 1 or 2 plus 1 points, so 3 distinct points that it passes through. No other degree 2 polynomial will pass through the same 3 points unless it was identical to p of x. So the only other quadratic polynomial that will pass through these 3 points is x squared itself. The graphs of two distinct polynomial functions cannot intersect in more points than the maximum of the 2 degrees. So for example, if we let p of x equals x and q of x equals x cubed, p of x will intersect with q of x at 3 distinct points. And if you graph that, and I've got the graph here on my graphing calculator, and I'll just center it there. Okay, so y equals x, or p of x equals x is the blue line, and q of x equals x cubed is the red curve there. We can see that it will intersect, 1, 2, at 3 points. But it will not intersect at, say, 4 points or 5 points or 6 points. This point here, what I've just stated here, sets the maximum number of intersecting points, not the minimum. So it's possible that two distinct polynomial functions may not intersect at all, and that's fine. So for example, p of x equals x squared plus 1, and q of x equals negative x squared minus 1, so a concave up parabola with a vertex at 0, 1, and a concave down parabola with its vertex at that -1 will not intersect at all. However, if the two parabolas, I move the concave up parabola down and the concave down parabola, move that up so that the two parabolas intersect with each other, they'll intersect at 1 or maybe 2 points, but no more than 2. So if we let, for example, we define another polynomial, let r of x equals negative x, r of x will intersect with q of x at 1 point. And I'll just bring the graph up here and just show you the graph. So that's the point between, so the intersecting point between the green line, so that's r of x equals negative x, and the red curve, this is a q of x equals x cubed. I'll just see if I can focus that a little bit better. Yep. And you can see that it'll intersect here at the origin, just at 1 point. Again, it cannot intersect q of x equals x cubed at more than 3 points.